Assalamu alaikum. Hello everyone. I hope you're doing great today. Today we're gonna go over TinkerCad. So today's class is gonna be an introduction of TinkerCad. What you will learn today, create first an account with TinkerCad, use TinkerCad to simulate circuits, and use TinkerCad and Arduino to blink an LED. These are the main outlines we will be doing today. List of materials. You're all gonna need a laptop and a Wi-Fi access. Why TinkerCad? TinkerCad is an online tool, means you don't need to download it into your computer. It is free, open source, no license needed, and it has an interface that has a lot of templates and models and components we can use for 3D modeling, circuit design, and simulation. So these are a few reasons why we're going to be using TinkerCad. So follow these steps first. First thing you need to do is to really create an account. If you don't have an account already, go to this link, and if I click on it, you're going to be here. So what you need to do, click on sign up. And there are so many options. I will send you code. You can basically join a class, and I will send you the code. Just click on this, and then the code I send it you, just enter it here, and then you will have access to the tool. All right, we go back to the presentation. So once you finish signing up by clicking on that button right there, and you select this option here, basically you will receive a code. I will send it to you, and then you can basically have the access. It will be like a teacher-student relationship, so I can follow what you do on your work. Okay. So once you enter the code, I will share with you, not this code. This is just a default value. You should have access to TinkerCad. Okay, so now let me go back to, instead of going on slides, let me go to TinkerCad. Well, TinkerCad we're going to be using today for circuit design, not 3D. And by the way, this is the toolkit that you will be designing for the components I'm going to give you. So you don't need to be in this platform here. I'm going to go to exit 3D design, and you need to select circuits and create a new circuit. These are just some of the projects I've done. What you need to do is click on create a new circuit. Takes a couple seconds, and TinkerCad is really very easy to use. On the right side here, you have all components, electronic components. I can just select all, for example, and drag down here, and you see there's a large portfolio of components, from integrated circuit to amplifiers, resistors, breadboards, motors. Anyway, we don't have to go through all these components for now, but I'm just going to show you basic functionality of TinkerCad, okay? And then as we go, you're going to learn about all these components. So the first thing you need to do, I want you to type in here breadboard. So the first thing I want you to do, type breadboard, or just scroll down here to find it, and just choose a small one so we don't occupy space. So what I do, you just click and drag. Click, hold your finger on the mouse and drag it. That's how you get here, okay? And so this is a breadboard. Now, same process. I want you to type LED or an LED. LED. LED stands for light emitting diode. So just think about it as a light bulb, basically, that we're going to turn on and off. Okay. So the same thing, you click and drag. Okay. If you don't want to type in, just basically scroll down to see the components that you need. Okay. So you can play, in this space here, you can basically just click on the component and drag it. So the breadboard, see, I can click and drag it like that. Let me explain you what this breadboard. This is where we're going to do prototyping, okay, and simulation. So you see that there are a bunch of holes like in this row here, and if I select any hole in this row, it will show some kind of circles, green circles, as you see. What that means, basically, that all these holes are connected. Behind, there is a metal plate that connects all these holes. So it means if we connect something here, it's the same thing as we connect, it's connected to this hole, okay? The same thing if we go on the top here. So all these holes are connected, okay? These are called rail, or you can just call them, really the name is not, doesn't matter, okay? The top also is the same thing, okay? And you see all these holes here are connected, and all top holes are connected. So note that here it says negative, and it's in black, and positive, it's in red, negative and positive, okay? In the middle, notice that the rows are not connected here, but the columns are connected. So this point here is connected to this point, connected to this point, connected to this point, okay? Same thing here. So when you hover with your mouse over the board, it tells you which points are connected. So if I want to connect something to this LED here, or light emitting diode, I can connect it here. I can connect it here. It's the same thing. I can, if I take this down here, for example, you see I can connect something to it. If I want to connect to this pin here, by the way, this is a light emitting diode, and the long leg, it's called an anode. That's the positive, and the short leg is called an cathode, okay? And that's what we're gonna connect the ground, okay? So with LED, it burns quickly. So what we need a resistor, okay? So I'm gonna, you can type a resistor here, or here is one in front of us. I just click and drag, and I'm gonna connect it. So right now, this end of, the LED is, I can basically rotate it. It doesn't matter, it have no polarity. So the both, you can connect from this end or that end, doesn't matter, okay? So this end is connected to the anode, okay? And, I can do this way, but no, these are not connected. If I want to connect them, I have to click on some wire and drag like that, okay? Then these two here are connected, okay? But then since I don't need a wire really, because I can just do this, I can just click on this resistor and drag it and pop it right there in that hole. So I have now this anode side is connected with that, okay? So that's good. Now imagine there is some kind of power coming here. Right now there is no power, okay? Even though it says plus and minus, there is no power source, coming to this board. So, but you just assume there is a positive here. This is a positive and this is a negative, okay? So what I want to do, I want to connect this side, which is the same thing as this side, okay, to the positive. So what I do, I click And notice when I click, it's like a wire come in my, in the mouse, and I can bend it, I can do whatever, okay? So I can click here, I want to make it nice and clean, I'm gonna click here, drag, click here, and let's connect this one to the positive side, okay? And if you know that basically positive, we always designate the wire by red color, so I can just go ahead and change red, okay? Now let's connect this guy, okay, to the ground. So I can go like that, and as we mentioned, we said that the top one here is the ground. So, and guess what? You guessed it right. I have to change the color. We don't have to change the color for, but just for ease of recognizing that that wire is ground. Okay, so it's good habit. We color code the positive side, negative side of the ground. Okay, so now I have this rail, but another good habit is to really have this also connected to that side. It means they are all ground, and I can connect also. I can go here or here, doesn't matter. Okay, just be nice and neat, and I can connect this to the positive. This one is connected to the positive, and you just change the color to red. Okay, you don't have to do this step here, but just wanna just be more nice. So right now there is no power, so this light is not turning on. We can since this is more like robotic and programming, I wanna, instead of just using a power, I can just type here power and put in 9-volt battery here, and put in some power here. Let's look for Arduino. Let's see what we can do with Arduino. And if you want to know more a little bit about Arduino, look into Arduino Introduction, okay, class. So I'm just gonna say Arduino and click again and drag this guy, okay? So you just drag everything here. That's nice, okay? So when Arduino is plugged to you see this plug here, USB, means it's already plugged to a laptop and it's powered, okay? So we're gonna get our power voltage from 5-volt basically from Arduino board. So now let's do this. Let's connect pin, without getting into details in this class why we're connecting pin 13. So we're just gonna go pin 13, and we're gonna go to here. Okay, and then we're gonna go ground. You see where the ground is? And then we're gonna go like that. And as I said, a good habit, just keeping everything color coded. Okay. Now, and to know there is nothing. This is basically Arduino board is a microcontroller prototyping board. We're gonna program this microcontroller right here. Okay. So next step, I want you to click on code. Okay. And I already did this, but let's do it again. Okay. Okay. So we want to program. Let's close this. Okay. We want to program this microcontroller basically to turn this LED on. Wait for, let's say, 1 second, and turn it off. And keep turning on and off and on and off repeatedly, okay, non-stop. So we want to blink this LED many times. So the way how we do it, just like the block codes, you're probably familiar with these block codes already. So we're gonna use, we go to control, okay? And we're gonna choose this control block here, on start. When we're gonna click on start simulation, what we need, we're gonna need forever block, okay? And then we wanna basically from here, this pin, okay? We wanna send some 5 volts to this pin right here, okay? This pin 13. So let's look for outputs, okay? And there is a built-in LED, if you see it. Right here, it was hiding on top. So we click and drag this built-in LED right here, okay? We're gonna set it to high, okay? And then we're gonna go to control here. We wanna wait, so there is a delay function right here. We wanna wait, let's say 1 second, okay? And now we're gonna turn on this built-in LED. The built-in LED is right here, and it is connected basically to this pin 13, okay? So we're gonna use this variable, which control this, which is connected to that, to basically send voltage to pin 5 volt. We're gonna send 5 volt to pin 13. So you can, then again, we're gonna need to go back here and click and copy this one, okay? So this time we're gonna make it low, so we're gonna turn it off. So by the way, high in computer is basically, or microcontroller here is 5 volt, okay? That's what's high, okay? And in binary number means number 1, okay? Low, anything really below 2.5 volts, like 0 volt, okay? So that's what low is. So we're gonna go back again to control, and we're gonna select wait 1 second, okay? So, you know, let's try this, see what's gonna happen. So I'm gonna click on simulate. Notice the LED is turning on and off. At the same time, this built-in LED, notice that it's turning on and off. And if you don't see it because it's green, I can always click on the LED and change the color. Let's say green, okay? Now you can see it looks nicer, okay? And by the way, also you can change you can go to this palette here and change the resistance value of this resistor. See here it's 1 kilohertz. I can go that shoe thing. It's basically a symbol for ohm. Okay, it looks like a horseshoe here. Okay, so if I do, look what happened when I do 1 ohm. Okay, I think I'm gonna burn it. Okay, because 1 ohm is not enough. That's why it's giving me this this symbol. It's not good. Okay, so we should have at least like, let's say from 220 ohms. Now that issue is gone. Okay, so right now you built a code, and we will talk about why actually we choose 220 or 1000 kilo ohm in later classes. I will be talking about Ohm's law, but for now, just get the hang of TinkerCad. And thank you, and I'll see you soon.